Okay, let's start taking a look at this. Thanks, everyone. Great. This is the correct pen. Good. All right. Where is my cursor? Right there. Sweet. All right, so we're looking at 15. And I think the series is x cosine of x squared over 2. And we're supposed to get a series for that. So if you have any kind of an idea about this, you would probably first, hopefully, you would look at the list of series, or you would recall the list of series you had memorized, and you would see if this is any one of them. And it is, but it's not. What I mean is, sure, we have a series for cosine, but we don't have a series for x times cosine. So if you got that far, but you're not quite as experienced, then you would probably say, all right, I don't have this series, so I need to go ahead and construct it from scratch, which would be bad. The derivatives here are very... yeah, time-consuming. These are time-consuming. More time-consuming than actually it needs to be. So there must be a trick here. The trick is to look at this as the following. Look at it as x times the series of cosine. So if you do it this way, you get x times... well, what is the series for cosine of x squared? Those are the even terms, or even power terms, so 1 minus 1 over 2 factorial, don't forget the factorials, x squared over 2 squared, plus 1 over 4 factorial, x squared over 2 to the 4th power. That's 3 terms, I need 1 more. 1 over 6 factorial, x squared over 2 to the 6th power, all the way over to negative 1 to the n, x squared over 2 to the 2n power. And I'm going to just rewrite this one more time. And I'm going to keep the x's and the other coefficients separate. So first of all, when I distribute, that'll be x minus 1 over 2 factorial 2 squared. X to the 2 times 2 is 4, plus 1 more is 5. Plus 1 over 4 factorial 2 to the 4th power. X to the 2 times 4 is 8, plus 1 is 9, minus 1 over 6 factorial, 2 to the 6th power, times x to the 12 plus 1 is 13, plus negative 1 to the n, 1 over, oh, you know, I forgot the 1 over n factorial here. 1 over n factorial 2 to the 2n times x to the 4n plus 1. And that's my series. So again, not difficult, but there is a trick to it. You have to remember you can multiply a series by any factor you like. Yeah. It is 2n factorial, thank you. Ooh. It's 2n factorial, thanks for that. 2n factorial. Let's just rewrite that. That's still ugly, isn't it? That's better. Okay, next.
To the right a little bit.
Hmm?
Can you scroll over to the right a little bit?
Yeah. The next part of this is just a term-by-term differentiation. So f prime, that's equal to just the derivative of every term. So the derivative of x minus 1 over 2 2x5 plus 4 2 to the 4th x to the 9th minus 1 over 6 factorial 2 to the 6 x to the 13 plus negative 1 to the n 1 over 2n factorial 2 to the 2n power x to the 4n plus 1. So you're just taking a derivative of everything. So the major trick here is realizing that the only thing you need to take a derivative of is x. Everything else is a constant. You can just float them out in front and deal with them later. So the derivative of x is 1. I'm going to leave this alone, let it float out in front, and then just take the derivative of x to the 5th power. That's 5x to the 4th. Same thing here. Take this, float it out in front, only take the derivative of x to the 9th. That's 9x to the 8th. Minus. Leave that alone. Just take the derivative of the x. And even when you get to the general term, leave this alone. Leave this alone. Just take a derivative of x. So that's 4n plus 1 x to the 4n power. And then you could probably leave it the way it is. But if you want it to be nice, you can start stacking things. 1 minus 5x to the 4th over 2 plus 9x to the 8th over 4 minus 13x to the 12th over 6 plus negative 1 to the n 4n plus 1, don't forget the parentheses, over nn. That's a nice looking answer. Maybe I shouldn't say it's nice looking, it's better looking.
It's easier.
It's a lot prettier. Easier. Still pretty ugly though. That's a really ugly series. The next thing we're going to do is take the derivative of every term, or the integral of every term. So every term needs to be replaced with t, so this becomes t. This becomes, again, leave the coefficient alone. You're not going to do anything with it. N plus 1 dt. So it looks very intimidating. It's not. You're only taking the integral of the t part. Everything else is constant.
With all are all those equal signs equivalent?
Yeah, they are. Because we have the infinite series here, they're exactly equal.
Okay.
Okay, let's move on. Let's do this. Integral of t, 1/2 t squared, minus 2 factorial 2 squared, integral of t to the 5th, 1/6 t to the 6th, very nice, plus 1 over 4 factorial 2 to the 4th, integral of t to the 9th, 1/10 t to the 10th power, minus integral of t to the 13th power, good, plus dot 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 negative 1 to the n, that's constant in terms of t, 2n factorial, that's also constant in terms of t, 2 to the 2n, that's constant in terms of t, and let's see, 4n plus 1 plus another one is 4n plus 2, and t to the 4n plus 2 from 0 to x. I'm going to pause here for 1 second. Yeah.
When are we saying things are equivalent and when things are approximate?
We're going to be equivalent if you have the general term implying an infinite series. You're going to be approximate if you have to truncate the series. So if you're only using the first 2 terms, no general term, then it's approximate. Okay, all that's left is a little bit of cosmetics. If you substitute x, all the t's turn into x, right?
Yeah.
If you substitute 0,
You get 0.
all the terms are going to be 0. So it's enough just to write all the terms with an x. So the integral from 0 to x of fit dit, that's going to be equal to 1/2 x squared. You know what? Let's make that x squared over 2. Minus x to the 6th power on top of 2 factorial times 2 squared times 6. Plus x to the 10th power over 4 factorial times 2 to the 4th times 10. Minus x to the 14th power 6 factorial 2 to the 6th times 14. Plus, okay, negative 1 to the n. I think that's x to the 4n plus 2. 2n factorial, 2 to the 2n, and then 4n plus 2. Mind your parentheses. Make sure you setting those factors apart. Yeah. Okay, yeah, give me
In what circumstance would you need to change the center? How this one has like +2 before we change? What circumstance do you need to change it?
One more time from the beginning, what are you saying?
There was a question that we ended with with a +2 instead of like a +1, like the center like we had to change the center from, like, oh, the n had to be 0 or 1.
Oh, yeah.
So when do you have to change?
Under that circumstance, that's going to be when you take a derivative and you lose a term.
Okay.
Since we're not losing any terms, none of our terms differentiated to 0, we didn't have to adjust. Okay, that's it. Any last questions? Okay, we'll see you today after school.